Okay, you guys. Chapter 24 is a lot of nutrition. Nice to be back with you again. I'm going to do chapter 26 as well, and then that probably will be my last chapter. So um, hopefully you have gotten something out of these. So what you're going to find with this chapter is we've really shortened it down quite a bit because probably some of you will be taking nutrition in another class. You'll get some of this in chemistry as well. So I really just chose some things that I don't think that you'll probably come across in some of the other classes, just so that this chapter would be a little bit shorter because it's overwhelming, I think, to do all of this semester in 5 weeks. And so that's partly why we cut it down just a tad bit on this chapter, because I know that you'll probably get some of these things in other chapters. So you can skip through to the chapter until we get to the metabolism. And metabolism is important. You talk about anabolic processes, building things up, catabolic, breaking things down, like in digestion. Those are important. But you've talked a little bit about that, for instance, in the digestive chapter. So we're really going to kind of start where we left off in the digestive chapter with the liver, because we talked about it a little bit. But we're going to go through just a little bit more on the liver and not only its job in digestion, which was producing bile so that you could digest fats, but in this case, what else does it do? So what you have to start out knowing about the liver is that all of the blood that's coming from your intestines, so that means all the nutrients that have been digested and are coming into the bloodstream from the intestine, small intestine, all of that blood goes first through the liver. And the liver has a lot of jobs of processing those things. And when we talked about development in a fetus, we said that the liver was partially bypassed. Well, that's because the mom has already digested the food and her liver has processed that food. So it has some roles in processing, but it also has a lot of other jobs. If you tried to build something that was going to replace the liver, you couldn't get a power plant or a manufacturing plant that would do all the jobs that the liver does, because it is extremely important in our systems. Okay, so as far as those foods that are coming in from the digestive tract, the nutrients have been broken down into their basic components. So carbohydrates are now simple sugars like glucose in particular. So we won't talk about some of the other simple sugars because glucose is the one that the body uses. Proteins have been broken down into amino acids, and fats have been broken down into fatty acids and triglycerides. So one job of the liver is, as that food comes in from the intestines, is it's going to package those fatty acids. Remember that your body is about 2/3 water. And think about when you put oil and water together, what happens? Okay, so if you can picture that in your head, those are going to separate. So the water is going to be on the bottom and the fat's going to float on the top. They don't mix together. You can shake it up all you want, and for a little while they're kind of mixed, but you still can see the fatty droplets in that mixture, and they separate out. So lipids don't like water, and they're not going to travel very well in the plasma. And so the liver has to make them into a form that they can be transported through the body. And so packaging these fatty acids so that they can be transported, or some of them are going to be stored short term, maybe long term. That's an important role of the liver. Okay, so, and usually those fatty acids get combined with a protein because proteins are water soluble. And those proteins, we'll come back and talk about that when we talk about cholesterol, HDLs and LDLs. But that's one way of transporting those, is by hooking them onto a protein that's water soluble. Okay, so that happens in the liver. Plasma proteins, the one that we talked about the most was albumin. That plasma protein is produced by the liver. Okay, and there are others that are produced by the liver. All right, so that's the most important one. That's the one that we've talked about the most, but there are other plasma proteins as well. Those are all really important in maintaining the osmotic pressure of the blood. It also forms what are called non-essential amino acids. So essential amino acids are things that you have to have them in your diet. Your body cannot make those amino acids. But there are some amino acids, and there are a total of 20 different kinds of amino acids What do we make with amino acids? Proteins. Okay, so all proteins are made from certain combination of those 20 amino acids. Some of those your body can actually make, but if you can't make them, you need to have them in your diet. Okay, so those non-essential, the ones that your body can make, are being made in the liver. It also converts ammonia, which is a waste product of protein digestion, because proteins have a nitrogen in them. So some of you might, know that ammonia is nitrogen based, and so when the proteins are broken down, some of that nitrogen ends up as a waste product, and it gets converted into urea eventually for us, because ammonia, as you can imagine, is very toxic for us. And so that gets converted into a more easily transported and non-toxic form, which is called urea. And that's what's mostly in our urine. It stores glucose, so any extra glucose you might not need right now that is not going to go directly out into the bloodstream from the liver, but it might be stored short term. So sticking a whole bunch of glucose molecules together forms a molecule of glycogen, which is just a short-term storage, so that you go and you eat supper and then you don't eat for 12 hours. Where's the glucose going to come from to make the energy that you need to continue your normal body functions, just the basic functions? That comes from partially this stored glycogen. So when you're fasting and you're not taking in any carbohydrates and making glucose yourself, you can rely on some of these reserves that are found in the liver. Okay, so short-term storage. If we're going to store this long-term, where are we going to put it? Okay, if you said fat or adipose, that's correct. Okay, so that helps to regulate our blood sugar, make sure that our glucose doesn't get too high, because the liver can store it for short terms, but it also, when it gets low, the liver can churn out some glucose from breaking down the glycogen. It stores a lot of vitamins, only fat soluble vitamins. So if you know which vitamins are the fat soluble ones, okay, think about that. Vitamins A, D, E, and K. So if you take in excessive amounts of those, they can actually become toxic, because your body can store them long term. And, they're there for a reserve. You can't store water soluble. So vitamin C, vitamin B, you can't store those because they're water soluble. It conserves iron. So iron is used where? In the hemoglobin of the red blood cells. So this can help to store and conserve some of that, so that it's available for red blood cells to use. And we don't just simply excrete the iron when red blood cells get broken down. And then we all know that it has a lot of jobs in detoxifying, but also degrades the hormones that we produce. We don't want to produce hormones and have them floating around in our system forever. And so this will degrade and break down those hormones. So take a little time and look at this picture, because there's a huge amount of stuff going on in this. Some of this you've talked about before with the bile and so forth, but it's an extremely important organ. There's no way that you can live without it. You can get liver transplant, and your liver can actually grow back if you donated part of your liver, but it also can grow in the person that gets the transplant. So that's a good thing. But you cannot live if your liver fails you. All right. Okay, so now we're going to talk a little bit about cholesterol, because that's something we hear about all the time. It can cause huge problems for people. But what you have to really remember about cholesterol, first of all, is we always talk about the bad parts. And in reality, you have to have cholesterol in your bloodstream, because you cannot make things like steroid hormones. You can not make bile salts to digest fats. Vitamin D is cholesterol based. All the plasma membranes have cholesterol in them. And so you have to have cholesterol. If you are not taking it in your diet, which you could do that, and if you had high cholesterol, you might do that, that's not going to limit cholesterol, because your body needs it. And so the liver is going to create cholesterol. The bad part is that some people's livers make too much of it, and so they just have a genetic disposition so that they're going to make too much cholesterol, and their high cholesterol can cause them serious problems. And those are the people that we put on statins, things that are going to help to regulate or control their cholesterol. So here's where we come back to those lipids being transported by a protein. So this blue structure here is a protein, and it's bound to our lipoprotein, so lipid plus a protein. And also, this is the way that cholesterol gets transported. We're going to talk more about LDLs and HDLs in a minute. We'll look at those a little bit more closely. But because lipids are not water soluble, they have to be attached to these proteins. Okay, so here's our little diagram down here. So if you can remember this, HDL, angel wings, HDL is the good cholesterol. LDL, on the other hand, is the bad cholesterol. So when we get our cholesterol checked, let's say, I think last time I had mine checked, it was 170. So that's below 200. That's good. When I was younger, it was actually, hey, this is a good little teaching point. When I was younger, so let's say when I was 45, my cholesterol was about 130. Okay, so why, knowing what cholesterol is used for, pause this just a minute and see if you can figure out why now, at my age of 56, my cholesterol is 170. It's gone up considerably since I was younger. Okay, so if you pause that and you thought about it a minute, after a woman goes through menopause, she doesn't produce any steroid hormones anymore. She doesn't produce estrogen and progesterone. Her ovaries are not functioning. And so some of that extra cholesterol then ends up in the bloodstream, and the cholesterol rises. That can cause some problems, obviously, because it could get too high, but that's a normal event in a female's life. Okay, so when we look at these, we're going to talk about HDLs being the good type. And the reason, if you look at this picture over here, okay, so the little blue squares are the proteins. And so you notice that the HDL obviously is a little bit smaller as well, but they are mostly made of protein. So we have protein, 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 and then the green ones are, we've got a couple of cholesterol molecules. So an HDL, high density, proteins are more dense than fats. So high density lipoproteins are composed mostly of protein. Phospholipids that are in the lipid bilayer of the cell are made of that. It also is a way of transporting that cholesterol. The reason this is the good cholesterol is it's transporting cholesterol to the liver, and that becomes part of bile. Well, where's that going to go? That goes into your digestive tract, and you excrete it in your waste. Okay, so those HDL protein envelopes form and transport that cholesterol, and in this case, pull it away from the arteries, taking it away from places where you don't want it to be. You don't want to make those plaques in your artery walls, and instead taking it to a place where it's going to eventually become part of your solid waste that you're going to excrete. So that cholesterol is destined for getting broken down, in other words. Okay, LDLs are the bad cholesterol because, first of all, they are very high in lipids, right? And that's what makes them low density. L stands for low density. Fats are not as dense as proteins. Very rich in cholesterol. So lots of cholesterol. Let's go back to our other picture here. So look at this molecule. Lots and lots of cholesterol in that molecule, and only a few proteins in that molecule. Okay? So that's our bad cholesterol. It's bad because instead of going to a place where it's going to get degraded, it's the type that makes plaques form. So when you get your cholesterol checked, they do more than just the total number of 170. They also break that down into how many good and bad cholesterol molecules do you have? What's the ratio of those? Okay, there is one more category, the very low density, but they don't usually compose much of your cholesterol. They're a very small portion of the cholesterol, so we don't usually talk about those a whole lot, but they are mostly lipids. Okay, and then these get transported as something called a chylomicron. They're mostly triglycerides. We won't talk about those a whole lot, but chylomicrons is a term that you might see again at some point. Okay, so this picture is good because it shows you what cholesterol, the bad cholesterol, LDLs, are doing. They're making these plaques on the walls of your vessels, and eventually that can cause clotting, which obviously is a bad thing. All right, so here's our different types of cholesterol molecules. So here's our high density, our good cholesterol over here, mostly protein, very small, um, lots of protein wrapped around some cholesterol. The low density, and then these are really big, these very low density, but there aren't very many of those, okay? And then chylomicrons, this is how so when we digested fats, we talked a little bit about this, that the bile breaks down, helps to emulsify the fats, then the lipase digests it, and then those fats, because they can't dissolve in the blood, in the watery solution of the blood, and they're also large, so they have to go into circulation via the lacteals into the lymph, and eventually they get transported through the blood or into the blood as a chylomicron. Okay, and so that's where that term might have come up before. All right, so regulating that plasma cholesterol, yes, what you eat can make a difference, a huge difference, obviously, if you're eating stuff that has a lot of it. But like I said, there's always going to be this basal amount that your liver makes, and that's genetic. We can't do a lot about that. And yes, you can help to regulate it by what you eat and avoiding these things like saturated fats that have more cholesterol in them. So the things that are solid at room temperature are the things that are bad in reality. So things like butter, margarine, shortening, those are the things that would be the saturated fatty acids. The unsaturated fatty acids would be, the vegetable oil, olive oil, things like that. So those unsaturated fatty acids actually help you to excrete cholesterol and make bile salts to help reduce your cholesterol levels. The trans fats are healthy oils that then get converted into a solid form. They're the worst type. So you might see that on packaging, contains no trans fats, because we've learned that those are actually the ones that increase the LDLs the most. And in addition, they reduce the amount of HDLs, or your good cholesterol. So what other kinds of things are going to contribute to that? Your genetics are a big part of it. What you eat is a part of it, but also smoking cigarettes, drinking lots of coffee, having a lot of stress. All of those things tend to lower your good cholesterol, your HDL. Things that will help you to increase that HDL would be exercise. Here comes that estrogen I was talking about earlier. Women don't produce any estrogen after they go through menopause. And so this is part of the problem with postmenopausal women. And when they start getting things like heart disease, because it increases the HDL. So now we're going to have less of the HDLs without that estrogen. And it also helps to keep a little bit of that LDL down. So that's a problem. Body shape kind of is an indicator of what category you are in. So the apple versus the pear, which I'm going to come back to in a little bit. All right, so imbalances, the LDL to HDL ratios used to be used as a potential disease. It's not as reliable as they used to think it was, but LDL levels overall and there are other risk factors that you have are really now what they use to determine if you should be on a statin or if you need to change your lifestyle or eating, increase exercise, and so on. All right, so those statins are cholesterol lowering drugs, so about 10 million people. The bad thing I've found about those from people that have taken them is that they tend to have side effects that people really don't like, and actually can be painful. Like I've heard a lot of people talk about joint pain with those. And so it makes them less likely to take them. And so If you don't want to take your medication and your cholesterol is high, that's going to be potentially a problem down the road. Okay, now we're going to switch gears to body energy balance. And energy intake, obviously, through your foods that you're eating, output. You actually, whenever you're working, it's like when you drive your car, why does your car feel hot afterwards? It feels warm because some of that energy from the gas is not getting converted to useful energy, but it's getting um, left off as heat. And we do the same thing. So our body warms up and heats up. You can never have a conversion of energy without losing some of it as heat. Okay, so we have that that's lost as heat. We have the part that's actually doing the work for us. And then the extra that we take in is going to be stored either as fat, which is long-term storage in the adipose tissue, or as glycogen. Where was that? In the liver. Okay, so we use some of that heat because it helps to keep us warm. So if you're cold, you might be doing jumping jacks or jogging in place, and that's because that helps to generate some heat. But it also helps to just simply maintain our normal body temperature. So we're not, if we go outside on a cold day, our body temperature is not going to drop like it does in something like a lizard that can't produce body heat the way we do. Okay, we have a huge problem, as we all know, with obesity in our population. And this is across the world, but the United States has a huge problem with it. And so we use different indicators of that obesity. So body mass index is kind of the current way that we measure that. And you look at body types along this chart down here. So this is, these are the good areas to be in for that body mass index. So 18 to 24, I would guess that the average one of us, is more in these categories. This would be a very thin person down here, and that can have its own problems. But 2 out of 3 adults are estimated to be overweight, and 1 out of 3 being obese. So that's 1/3 of our population. And the problems that then arise from that, heart disease, joint problems, diabetes, and so on. So diabetics, and we're not really talking so much here about the type 1 diabetes, which is usually shows up when people are children, and it's an autoimmune disorder, but we're talking about type 2 diabetes, the type that is developed as we get older, and we're actually seeing younger and younger people develop this, but it has a lot to do with our diet. So it's a sad state of where we are, but that's where we are. So 17% of children are obese compared with only 5% 40 years ago. So when I was growing up, there was really virtually no one that I grew up with as kids that were obese. And now we see, not quite a fifth, but almost 1 out of 5 kids being obese. Huge problem. Not sure how we're going to solve that. Okay, so how is that regulated? How is your hunger regulated? There are several hormones. We're not going to talk about all of these, but just to mention a few, glucagon, that increases your blood sugar, does the opposite of insulin. Epinephrine stimulates it. That's the fight or flight hormone. Insulin helps you store or cells take up glucose. Cholecystokinin, these are things that you produce right after you've eaten. So right after you've eaten, you probably aren't hungry, right? That's partly due to the production of insulin and cholecystokinin that are helping you to digest your foods that you've eaten, and cells take up those nutrients. Ghrelin is one that the stomach produces, and it stimulates. So that's, potentially one that could be a problem for people that have difficulty with their food intake and eating too much, have too much of an appetite. But fat cells actually produce a hormone called leptin that suppresses your appetite when it's really high. So the balance between those hormones can definitely be off. Someone can produce too much or too little of these, and that can also contribute to obesity. Okay, long-term regulation are things like the leptin levels, but that's not a magic bullet. There's all kinds of treatments we know out there for obesity, and many of them can be successful. A lot of it depends on the person, right? Okay, what else? Temperature. When it's hot outside, you don't usually feel very hungry, right? When you're hot. If you have a lot of stress, now there are people that are stress eaters, and then there are people who don't eat when they're stressed out. When they're really stressed out, they would lose weight and get thin. So that kind of depends on the person and the psychological factors. Viruses of certain types, having a cold or bronchitis, that when you're sick with various things, sometimes you feel like you have a normal appetite, and then there's a lot of things that you get that make you just have no appetite at all. Being sleep deprived can make you eat more, and that's probably a big problem in our culture, I would guess. And then the gut bacteria, there's a huge amount of study going on about gut bacteria now. And the things that you eat is what determines the kind of bacteria that you have in your gut. And those can really influence your appetite. Okay. And that's really diet based. So if I looked at somebody from different areas of the world where their diets are very, very different, the microbes in their gut would be very different, that reflecting that difference in what they eat. Okay, so now we're going to switch gears a little bit again here, talk about metabolic rate. So metabolic rate is combining all the chemical reactions that are going on in your body at one time. Basal metabolic rate is taken when somebody is in a post-absorptive state. That means they haven't eaten recently. Usually they want people to fast for 12 hours. They're laying down, they're relaxed, they're not stressed. In other words, they're basically burning no extra calories other than what their body just simply needs to survive. So this is somebody getting their basal metabolic rate. So they're measuring their oxygen intake and their CO2 production. So the essential calories only. So when you look at something like, they don't. I was hoping they had hummingbird on there, but they don't. A rabbit or cat or dog, they have a higher metabolic rate. A shrew has a really high metabolic rate. They've got to be eating all the time, right? And they're burning lots of calories all the time. And a lot of this comes down to surface area to volume ratio. Okay, which we're not going to talk a lot anymore about, but that's really what it comes down to. Okay, so metabolic rate, yes, there's definitely a difference in people on what their metabolic rate is. And so, you can't change that necessarily. You can in some ways, because muscle tissue burns a lot more calories than fat tissue. So in that instance, you can definitely have a role in changing and regulating your basal metabolic rate, but it's not going to happen overnight. You're going to have to build up muscle tissue and lose some of that adipose tissue. We all are going to have certain factors that we can't change. Men have higher metabolic rates than women because they generally have more muscle mass. As we get older, we get less muscle mass, and so our metabolic rate usually goes down. Your body temperature. If I took mine versus yours versus someone else's, we all have a little bit different temperature, and those people with higher temperature usually means they're burning more calories and making more heat, and so they might have a higher resting temperature. That's kind of an indicator of their basal metabolic rate. Stress levels, thyroxine being produced by your thyroid gland, that regulates your metabolic rate. And if you don't have enough, it's going to slow everything way down. I answered this question already. So if you didn't catch it, stop for a second here and see if you can answer that question. Why does your basal metabolic rate decline as you age? Decrease in skeletal muscle. Because muscle burns more calories than any other kind of tissue. Okay, so keeping active and fit as you get older is a key. Okay, so now let's move on here a little bit and talk about total metabolic rate. I had to take a break there for a minute, so sorry for the kind of chopped up part there. But your total metabolic rate is all the things that your body does expending energy. And you'll notice that, a lot of it is just baseline metabolic rate. Your physical activity is obviously going to change a lot depending on the person, but it's how many kilocalories do you use up to fuel all of your activities. Okay, so um, skeletal muscle activity. So even if you're at rest, if you have a lot of skeletal muscle mass, you are burning more calories than somebody else at rest that does not have skeletal muscle mass, because skeletal muscle burns more calories even at rest than other types of tissues do. Okay, it also takes energy to digest your food, and is greatest with protein and alcohol ingestion. Okay, so your normal body temperature, 98.6. My guess is that for a lot of us, and I know this is the case for myself, I actually run a little bit lower than that, and I think a lot of people do. But enzymes function the best at our body temperature. And body temperature is a homeostatic thing, it's within a range. Okay, so we can get up to 106, 107 before things start to go really bad. And what happens at that point is proteins start to get denatured or broken down. So there's this, this window of perfect, temperature. So 37 degrees on average is where enzymes work the best, and we can't function without enzymes. If you increase it too much, you denature the proteins, and your nervous system would shut down. Temperature changes happen throughout the day. And so your body tolerates a range of temperatures very well. We can actually tolerate lower temperatures better than we can high temperatures. Okay, so how do we maintain that? What do we do with that heat that gets produced? And how do we lose heat? All right, so we've talked about basal metabolic. We've talked about producing heat by muscle activity. Thyroxine and epinephrine stimulate your metabolic rate, increase metabolic rate, and temperature affects that as well. So now let's look at the things that how we lose heat. Okay, so radiation, it's the heat that comes off your surface. So when they take a picture of someone that has all those kind of colors on the body, and the areas that are red or the warmest, that's where the heat's coming off. That's radiation. Conduction is to a surface. So you sit down you go to a football game in November and it's cold outside, and you sit down on a metal bench. Oh, you say, whoa, that's really cold. And the heat goes out of your back end onto that bench, and you lose some of your heat. That's conduction. Convection, I always like to think of a convection oven, because we all kind of know what that does, and that's air moving. So convection, moving air. So when you are hot and you want to blow a fan over you to cool you off, that's convection. And that convection of blowing the fan across you helps to evaporate the sweat that's on the surface of your skin. When sweat evaporates, that takes the heat out with it. Okay, so any heat that's in that water, that's being evaporated is going to go out. So that helps to cool you off. And convection helps to evaporate that more quickly. So that's why it feels so good to blow a fan on you. Okay, so why are those really high body temperatures dangerous? Well, we have to look at our core temperature versus our shell temperature. So our core is what we really want to maintain at 37 degrees. And we dissipate that heat off of the surface of our skin. So when we are really working hard, our core temperature and our extremities can also be very warm. But normally, our extremities are much cooler, okay, than our core temperature. Our heat exchange is done by moving blood through the system and then shuttling that blood out to the surface if we want to get rid of the heat, or making sure that that blood stays in our core to keep that heat in our core. So when we're in really cold temperatures, we want to maintain our core body temperature, whereas we might get frostbite in our hands and feet. Okay, so here's our picture that shows or helps you to kind of see that those different ways of losing heat: evaporation, radiation, conduction, convection. And if it's really hot out and you're sweating, that wind feels really good. If it's cold out, not so much, right? Because that also is going to take heat off of the surface of your skin. Okay, so spend a little bit of time looking at that and understanding what those 4 different types are. So that evaporation for us is primarily how we cool ourselves off. And the key is that the water, in other words, our blood, absorbs heat before it evaporates. So we actually lose moisture several different ways. We think of sweat, but there is also always moisture that's being lost with every breath that we breathe out. When you're outside in the wintertime and you blow your breath and you can see it, why can you see it? Why do you see your breath? That's because there's moisture in that air, and in that cold, it's going to crystallize. And so you see that moisture crystallizing in the air. So our mouth, our skin, our lungs are all losing some perspiration all the time. So even though we don't feel moisture on the surface of our skin, most of this comes from our mucous membranes, by the way, but it accounts for 10% of our heat loss. Then we can ramp up our perspiration so we can sweat a lot or a little, up to 1 to 2 liters per hour, even we can produce, where you're drinking a whole lot in order to, just maintain what you're losing. Okay, replace what you're losing. My son was fishing over the weekend, and he said he drank something like 120 ounces of water because it was so darn hot on Saturday, and he was sitting in the sun and he was sweating so much, and he didn't have to go to the bathroom, and he still felt thirsty when he got home. Okay, so that's towards the extreme end. If we're just doing a regular workout, yeah, we do lose some heat, and we have to make sure that we continue to take in water in order to replace that. Okay, something like a lizard, by the way, is not able to produce heat of its own, and so it changes with the body temperature. But this picture shows you, or helps to make visualize what those 4 heat loss mechanisms are. The hypothalamus is really what regulates our body temperature. And so when you get sick and you have a fever, your hypothalamus has a control center in it that raises your body temperature goal, and your body will respond by making you shiver, making you feel like you want to put blankets on, anything that can help to raise that body temperature. Why does it want to do that? Because it helps to kill bacteria and virus, to increase that temperature. They're sensitive to excess temperature as well, but it also helps to speed up our metabolic reactions. All of our enzymes are going to work much more rapidly, so it helps us to fight off that faster as well. Okay, so what if instead of wanting to get rid of heat, we want to retain our heat? Constricting the cutaneous. So in your skin, the vessels will constrict, okay, especially in your extremities. So you think about when you get cold, what parts of you get cold first? Your fingers and your toes, right? And you can see the blue coloring on this baby's feet because they're cold, right? So that's bringing that heat back into the core, less blood flowing out to the surface. So constricting the vessel, so less blood flow out to the surface. So frostbite can become a problem. So you're giving up that, or you're conceding that to that cold, but wanting to keep your core temperature where it needs to be, okay, to maintain life as long as you possibly can. You're going to shiver because muscle contractions help to produce heat. You might jump around or run in place and so on. Okay, babies actually have very little fat and they have a lot of surface area. So they lose their heat very easily. And so their body temperature fluctuates more than ours would. They have something called brown fat. Brown fat can actually, we have white fat. Okay, it looks kind of yellow, but we call it white fat. Brown fat actually can produce its own heat. So we don't have that as adults. Animals that live in the Arctic or swim in cold water, they have brown fat also, so they can produce heat. We also would increase our thyroxine because that helps to increase our metabolic rate. This would be more of a, over hours or days type of effect. And infants are primarily doing that because they can't regulate their body temperature nearly as well. Okay, so losing the heat, we talked a little bit about each one of these things, but your vessels in your skin are going to dilate. You look flushed. If you have lighter colored skin, you can see that. You sweat. That sweat gets evaporated. You want to get into the shade. You want to have a fan or air blowing on you. Definitely light colored clothing works so much better. Like you can't imagine how much more heat you will absorb with dark color clothing. So wearing light color clothes, and this guy's wearing black shirt, so that doesn't really help a lot there, does it? All right, so hyperthermia, excess temperature, very dangerous. And who tends to have those problems more? Okay, if you said older people, yes, because they have a harder time regulating their body temperature. But that elevated temperature can have a neurological effect, depress the hypothalamus. And so that's kind of your control center of a lot of your body functions. So if the hypothalamus goes, lots of things will start to shut down. So we've got hyperthermia, where your body temperature is increased, and then heat exhaustion, where you're dehydrated, your blood pressure drops because you've lost a lot of fluid, and it can lead to heat stroke, which is extremely dangerous. And if someone's not sweating and they're very pale, that's an indicator that they have heat stroke. Hypothermia, the opposite, can lead to having a heart attack, cardiac arrest. Stops the heart. They'll go into a coma usually first. There's a lot of delirium that can come before that, but it's obviously a very, very serious problem. If we would say you freeze to death, basically. Fever is a controlled hyperthermia. So your body's actually doing something for you when you have a fever. It makes you feel crappy, and you feel better if you take something to reduce your fever. But in reality, it's helpful because it's helping white blood cells, injured cells and macrophages increase their activity and work faster. Okay, so it's actually a good thing as long as it doesn't get too high. All right, so take a little time, stop the video here, go through this and look at some of these warning signs. So you would expect somebody to look really red, but they actually look kind of pale, and their skin is kind of clammy and cool when they have heat exhaustion. So read through that a little bit. Okay, developmental wise, we would naturally say just common sense. If a woman doesn't have enough nutrition when she's pregnant, that could be bad for the developing fetus. But it's definitely the case if she doesn't have enough calories, proteins, vitamins, that can lead to serious permanent mental deficits and learning disorders. So malnutrition during pregnancy is a huge problem. We don't talk about that a lot. We maybe don't see that a lot in the United States, but it definitely happens. Type 1 and type 2 diabetes. Type 1 is the type that develops as children. Type 2 is a lot of times a result of lifestyle, diet, being overweight, and so on. And then as we get older, our metabolic rate declines. So we tend to gain weight as we get older because we lose skeletal muscle mass. So the moral is continue to be active, continue to try and maintain that muscle mass. You're not going to be able to maintain the same muscle mass you have right now in your 20s, but you can retain more muscle mass by exercising regularly, doing weight-bearing types of exercise. Okay, I'm sorry, the people that like the swim classes, yeah, it's exercise, but it's not weight-bearing. So it's not nearly as effective as doing something like walking or lifting some, weights. It doesn't have to be a lot of weights, but making sure you maintain your muscle. Okay, medications. We didn't talk about the things like potassium and sodium, but we'll talk a little bit about the balance of those in chapter 26. But there are all kinds of medications that can cause cause side effects, but they're being given for all these age-related problems. So they can influence the nutrition. So taking diuretics can increase the risk of hypokalemia, which is low potassium. And if you remember how muscles function and nerves function, sodium and potassium are crucial to that and a balance of those. So hypokalemia, low potassium, can definitely be a problem because it's going to affect resting membrane potentials and so on. Some antibiotics interfere with digestion and absorption. Plus, you're also killing a lot of your own good bacteria when you take them, and so they can result in diarrhea. Laxatives oftentimes will decrease the absorption of fat-soluble vitamins because they're making things go through the system faster, and the fat-soluble vitamins have to take time. You have to have fats in your diet also in order to absorb those fat-soluble vitamins. Excessive alcohol consumption can definitely lead to malabsorption, vitamin and mineral deficiencies, easy for me to say, cause metabolic problems, and now you know why, because it affects the liver, and the liver is key to those metabolic issues. Okay, here's where we come back to that apple versus pear. Okay, so apple is kind of the warning sign type of body type. Pear is more where you would want to be, but metabolic syndrome is a cluster of risk factors. So if you have all of these, then you are at much, much higher risk. So that's why they give all the little surveys. So the factors are waist circumference, your blood pressure, your blood sugar, your triglycerides, and your HDL cholesterol being too low. That typically goes along with this apple shape, or sometimes we'll call them barrel-chested people, especially when we're talking about males. But that apple shape, carrying the weight in your upper body area and having a large waist is usually a warning sign. Okay, so we want to make sure that we do all we can to take blood pressure medication, decrease weight so we can decrease the waist circumference. If increased weight can also cause diabetes, so we want to maintain our blood sugar levels where they need to be, triglycerides from the fats that we eat, and exercise helps with all of these things. It helps to get rid of triglycerides, balance the glucose, maintain good cholesterol, keep your weight down, and so on. So that's one of the biggest changes that a person needs to make if they get diagnosed with diabetes. Okay, this happens in animals as well. And we could show pictures of dogs or other animals, but I want to show you a picture of my horse. So my horse looks a little bit like this. You can't see the side of his neck, but this fatty accumulation up at the top of this neck, we call it a crest. Equine metabolic syndrome is just as real as diabetes in people and causes all kinds of digestive problems. For my horse, it caused him a lot of foot problems and being lame and just all kinds of different things because it affects blood flow, it affects vessels, the health of the vessels, and so on. We see all kinds of problems that develop from that. Okay, so I'm going to go through just one question with you here, and then I'm going to let you be done with this. Hopefully, again, you're not watching the entire of all of these things, but hopefully you're picking and choosing the things that you're having trouble with. So one quick question for you. So shut it off, turn it back on, and I'll give you the answer. Okay, so for this one, Number one would be the choice there. The cholesterol is being destined for destruction. So we want high density lipoproteins. We want to decrease our low density lipoproteins. Okay, so we will, I'll be back with you for chapter 26. And that'll be the last time I see you, but hopefully things are going well for you. Make sure that you ask if you have any questions for sure. All right, so hopefully everything is going well. You're almost there. You're getting to the end, and it's tough for this kind of a class to do it in 5 weeks. So keep going. You're gonna make it.